Right now, in the time it takes you to blink, a photo you just posted traveled through underwater cables, bounced across dozens of servers, and landed on someone's phone on the other side of the planet. How is that even possible? In the next few minutes, you will see exactly what happens the moment you hit send. No jargon, no engineering degree, just a calm walk through the real machines and wires that make the internet feel instant. Here is the first big reframe. The internet is not a fuzzy cloud floating somewhere above your head. The internet is physical. It is real cables, real wires, and real machines spread all over the world. Think of it like the road system. Roads, bridges, and traffic signs are everywhere, but you only notice them when you drive. The internet is the same. It is always there, quietly carrying tiny pieces of information from one place to another. So what does sending actually mean? When you send a message, a photo, or a video, your device does not push the whole thing across the world in one big lump. That would be slow and fragile. Instead, your device chops your message into many tiny pieces. These pieces are called packets. Each packet carries a small part of the message, like a single page torn out of a long letter. Each packet is small, simple, and easy to move. If one packet gets delayed or lost on the way, only that piece needs to be resent, not the whole message. That is part of why the internet feels so reliable. Now, how do packets actually travel? They do not take one straight line. They hop from machine to machine. These machines are called routers, and you can think of them as traffic directors at every junction. At each router, the packet pauses for a tiny moment. The router reads the destination, decides the next best step, and sends the packet on its way. It is like a relay race where every runner only needs to know who is next. No single router knows the full path. Each one just makes a smart guess about the next hop. Multiply that by dozens of routers, and your packet quietly weaves its way across cities, countries, and oceans. For this to work, every packet needs an address. So every device on the internet, your phone, your laptop, every server, gets a unique number called an IP address. Think of it like the street address of your device. Every packet carries two addresses, the address it came from and the address it is going to. That way, routers always know where to send it, and the destination always knows where to send a reply. Now let us zoom out and look at the physical backbone of the internet. The biggest, most important pieces are not satellites in the sky. They are actual cables lying on the floor of the ocean. These undersea cables are about as thick as a garden hose, but they carry almost all of the internet traffic between continents. Inside them are thin glass fibers, and pulses of light travel through that glass at incredible speed. These cables stretch for thousands of miles between continents. So when you message a friend overseas, your packets are very likely traveling along the ocean floor, weaving past fish, shipwrecks, and deep-sea trenches. So your packets travel through real cables. But where do they actually end up? When you visit a website, your request goes to a building called a data center. These are huge warehouses full of servers, humming away day and night. Inside a data center, rows and rows of servers store websites, videos, photos, and apps. When you ask for a page, one of these servers grabs the right files and sends them back to you, packet by packet. Big services like video sites or social apps do not use just one data center. They use many, spread around the world, so the server answering you is often a short trip away, not on the other side of the planet. But there is one problem. You do not type IP addresses into your browser. You type names like youtube.com, so something has to translate that name into the right number. That something is called DNS. DNS is basically the internet's phone book. You give it a name, like youtube.com, and it gives back the IP address of the right server. Without DNS, you would have to memorize long numbers for every site you visit. So here's the full picture. You type a name. DNS finds the IP address. Your request is split into packets. Packets hop through routers and cables to a data center. The server replies with more packets. your device puts them back together.